Have you ever looked up at the night sky and wondered where we go next? For generations, our eyes have been fixed on the stars. We have sent probes, rovers, and even humans into the vastness of space. We have walked on our own moon and peered into the deepest corners of the cosmos. But the ultimate dream has always been something bigger. It is a dream of creating a new home beyond Earth. This incredible ambition has a name, terraforming. It means transforming a world, making it habitable for life as we know it. For decades, one celestial body has dominated this conversation. That world is Mars, the red planet. But what if our focus has been too narrow? What if a frozen moon orbiting a distant gas giant could be our first true off-world home? So what exactly is this incredible concept we call terraforming? In simple terms, it means earth-shaping. It is the hypothetical process of deliberately modifying a planet, moon, or other celestial body to make it similar to Earth. The ultimate goal is to create an environment where humans, and eventually other Earth life, could live and thrive without the need for advanced life support systems. It involves altering its atmosphere, its temperature, and its surface conditions on a global scale. It is planetary engineering at its most ambitious, a project that would span centuries, if not millennia, and test the very limits of our knowledge and capability. We would likely start by introducing hardy, simple organisms like algae and lichens. These pioneering life forms would slowly convert the atmosphere, producing oxygen through photosynthesis. For as long as we have dreamed of living on other worlds, Mars has been our prime candidate. It is our celestial neighbor, relatively close and familiar. We have mapped its surface in incredible detail. We know it once had a thicker atmosphere and liquid water flowing across its surface. In many ways, Mars feels like a ghost of a planet that was once more like Earth. The challenges are immense, of course. Mars is cold, its atmosphere is thin, and it is blasted by deadly solar radiation. But the appeal of Mars is undeniable. It has a 24-and-a-half-hour day, remarkably similar to our own. It has polar ice caps that contain vast amounts of frozen water, a crucial ingredient for life. The soil contains minerals that could potentially support plant growth. Beyond the asteroid belt, orbiting the gas giants Jupiter and Saturn, lie dozens of moons. These are the Galilean moons, discovered by Galileo Galilei in 1610, Io, Europa, Ganymede, and Callisto. Let's start with Europa, perhaps the most famous of Jupiter's moons. On the surface, it's a sphere of water ice, crisscrossed by mysterious reddish-brown cracks and ridges. But the true magic of Europa lies hidden beneath this frozen shell. Data from the Galileo spacecraft strongly suggests that under the ice, there's a vast global ocean of liquid salt water. Scientists estimate this ocean could be up to 100 kilometers deep and may contain more than twice the amount of water found in all of Earth's oceans combined. Then there is Enceladus, Saturn's small icy moon. Giant plumes of water, vapor, and ice particles erupt from deep fissures near its south pole, nicknamed tiger stripes. These geysers shoot hundreds of kilometers into space. Finally, there is Titan, Saturn's largest moon, and a world that is utterly unique in our solar system. It is shrouded in a thick, nitrogen-rich atmosphere that is even denser than Earth's. Let us begin with the most fundamental requirement for human life, a breathable atmosphere. Mars has an atmosphere, albeit a whisper-thin one. The Martian blueprint for terraforming involves thickening this atmosphere, releasing more carbon dioxide from the polar caps and soil. However, one moon stands out as a remarkable exception, Titan. Saturn's largest moon already has a magnificent atmosphere. The problem isn't a lack of air, but the wrong kind of air. The next great environmental hurdle is temperature. Mars is the warmest of the bunch, but that is not saying much. The average temperature on the red planet hovers around a frigid -63 degrees Celsius. The moons of Jupiter and Saturn exist in a different league of cold. Europa has a surface temperature that averages around -170 degrees Celsius. Titan is even colder. However, the moons have a secret weapon, internal heat. The immense gravity of their parent planets constantly squeezes and stretches them, generating enormous friction deep inside the moons, creating enough warmth to maintain vast liquid oceans beneath their icy shells. Mars has a surface gravity of about 0.38 g or 38% of Earth's. This is the highest of any terraforming candidate outside of Earth. The final and perhaps most deadly environmental challenge is radiation. Mars has lost most of its defenses. Today, the red planet is bombarded with a relentless shower of solar and cosmic radiation. The moons offer different solutions. Their thick ice shells are incredibly effective radiation barriers. Titan's dense atmosphere absorbs radiation just as effectively as Earth's atmosphere does. The dream of terraforming is currently anchored in science fiction for one simple reason: we lack the technology. Consider the task of warming Mars. We would need to construct massive mirrors in space, using materials mined from asteroids. For a world like Europa, we would need robotic drilling technology capable of penetrating a crust of ice that could be tens of kilometers thick, before finally deploying a submersible to explore the hidden ocean. Energy is the fundamental currency for all these ambitions. We would need fusion power and vast solar power arrays orbiting the sun, beaming energy across the solar system. Beyond the technological challenges, terraforming opens up a complex biological frontier. We must also seed new worlds with life. This process, called ecopoiesis, is the deliberate creation of a new biosphere. We would need to turn to synthetic biology to create new forms of life. Imagine designing cyanobacteria that are incredibly resistant to cold and radiation, capable of photosynthesizing in the dim light of the outer solar system. Introducing life to another world brings the profound risk of contamination. What if we inadvertently trigger an extinction event before we even knew native life was there? The ambition to terraform another world forces us to confront some of the deepest ethical questions our species has ever faced. Do we have the right? Do we have the moral authority to take an entire planet and fundamentally alter its nature? This ethical dilemma becomes even more acute if we discover native life. If Europa's ocean contains even a single microbe, that world arguably ceases to be a blank canvas for our ambitions. It becomes a place with its own biological heritage. There are also profound questions about who gets to decide. A project of this magnitude would affect all of humanity, and its consequences would last for thousands of years. How do we ensure that the benefits of a second Earth are shared equitably? We would need to develop new forms of international and indeed interplanetary law and governance. For many, the answer remains unchanged. Mars is the clear and logical choice. Its proximity to Earth is a massive, undeniable advantage. A mission to Mars takes months, not the many years required to reach the moons of Jupiter and Saturn. Mars presents challenges that, while immense, are at least familiar and seemingly surmountable. The blueprint for terraforming Mars is direct: warm the planet, thicken the atmosphere, and melt the water. Finally, there is the power of the Martian dream itself. For over a century, Mars has been the focus of our collective imagination. This cultural momentum is a powerful force. While Mars makes a compelling case, we cannot ignore the profound allure of the moons. The single greatest argument for the icy moons is their vast, hidden abundance of liquid water. Mars has frozen water, but the moons offer ready-made global oceans. These worlds also offer a unique solution to the deadly problem of radiation. Their thick ice shells are one of the most effective radiation shields imaginable. We wouldn't have to engineer a shield. We would just move into the shelter nature has provided. Then we have Titan, the true wild card. It offers a unique combination of advantages: thick atmosphere for protection, vast energy reserves, and an enormous water ocean. It's a complete package. The moons force us to think beyond the Earth-centric model. A future on Europa might be a civilization of submariners. A future on Titan might be a society powered by methane, living under an orange sky. These represent a more radical vision of our future in space. So, where does this leave us? If we have to predict a winner in the race to establish the first truly self-sustaining off-world home, the most logical answer might be surprising. The winner will be the location that offers easiest access to water, energy, and protection. Of all the moons, Titan presents the most compelling case. Its thick atmosphere provides protection, its surface hydrocarbons offer energy, and its hidden ocean provides water. It is the only place where all the key ingredients for civilization are present in one location. Therefore, the most likely scenario is a dual-track future. Humanity will push for Mars, driven by the dream of walking on another planet. But the first truly viable city beyond Earth might be built under the orange skies of Saturn's greatest moon. Our journey has brought us to a profound crossroads. The choice between the red planet and the icy worlds is a choice between two fundamentally different destinies for humankind. One path leads towards restoration, the other towards adaptation. Mars represents a dream of familiarity. It is the story of bringing a lost world back to life, of creating a new Earth from the rusty dust of our neighbor. It suggests we can carry the essence of our home world with us. The moons offer a more radical and transformative future. To make a home on these worlds is to accept that our destiny may not be to replicate Earth, but to become something new. Ultimately, this choice will define what it means to be human in the cosmic age. Do we seek to spread Earth-like worlds throughout the galaxy, or do we seek to merge with the universe, adapting ourselves to its myriad forms? The decision we make will set the course for the next great chapter of our species' existence. It is a choice not just about where we will live, but about who we will become when we get there. The race to terraform a new world is not a competition with a finish line in the near future. It is a grand project for generations yet to be born. For us, the most important task is not to choose a destination, but to cultivate the spirit of curiosity that will get us there. Our role is to ask the big questions, to send our robotic explorers into the darkness, and to gather the knowledge our descendants will need. We are the generation that draws the maps and lays the foundations. The journey ahead is long, but it is not impossible. Every new discovery brings these distant dreams closer to reality. What seems like science fiction today often becomes the scientific fact of tomorrow. This grand ambition should serve as a reminder of the preciousness of our own planet. Earth is a world that has been perfectly terraformed by 4.5 billion years of natural history. Our dream of building new worlds should go hand in hand with protecting our original home. So, let us continue to look up at the night sky with wonder and ambition. Let us send our probes to the edges of our solar system. Let us dream of walking on Mars and swimming in the oceans of Europa. The story of humanity's future in space is an unwritten chapter. We may not live to see its completion, but we have the incredible privilege of writing its very first words. The journey is just beginning, and the universe is waiting. It is time to explore, to imagine, and to take our first steps towards becoming a species of two worlds, and then, perhaps, of many more.